Yes, welcome everyone in today's presentation. Yes, in this session, we are going to introduce ourselves to what we call data collection, which is a continuation of the topic that we introduced of data collection and presentation. So, in our first session, so that we looked at what we call the different types of data. We also defined what data is, and then we went ahead to classify the different types of what data. So from there we are going to see how we can do data collection. Okay, so having known that we have different types of data, we have what called qualitative data and then we have what called quantitative data, and then from quantitative then we divided it into different sessions where we have whereby we had what we call the uh, discrete, and then we had also have what we call continuous data. So in today's session we are going to have the scenario whereby we are going to see how we can collect data. After collecting data, how do we present this data into what we call, could be format, table format, could be how can we present this data using using graphs. How can we present data collected using graphs? How can we present data collected using pie chart? How can we present data using, let's say, line graph, bar graph? Okay, so all these are some of the concepts that we are going to cover into this session. So here to start with, we have a scenario, okay, that the school's science department is organizing a science fun day, okay, and then to make the event exciting and engaging, the organizing team want to know which science subjects students enjoy most, okay, and then the class teacher decides to survey the class to help plan the activities. Then each student is asked to choose their favorite science subject among math, biology, chemistry, and physics. The results are recorded using tally. Okay, this was an event, or the school was planning to organize what we call a science fun, whereby they want to see which subjects are most liked by these students in a certain school. So what the teacher decided is to go and ask students in a certain class which of the four science subject is their favorite, whereby we have chemistry, you have biology, you have mathematics, and then you have physics. Like, or some of you here at your school you could be having your have like you among these four subjects, you also have your favorite subject among these four. So what the teacher did a survey on. He conducted a survey asking different students to give him the idea, or to give them their view about the subject. For me, I like this. I like biology. I like chemistry. So students will give different suggestions. So after gathering this information that you've gathered, you've collected it from teachers, from the teachers collected it from the students. Again, you need to organize this table, this content, or this data in terms of what could be in the table format, so that it can follow, it can be analyzed whereby we have the name of the student, or you may not have name of student, but have the number of student, their favorite subject, and then get the total number. So like here, this is the collected data. We have the subject, we have the tallies, and then we have the frequency. Frequency represents the number of students who chose that specific subject. For this case, we have mathematics was collected. How many tallies? We have a bundle of 5, which is 2. We have 2 bundles of 5, and then we have 3, which when you add this 5 plus 5, then it gives you 10, and then with the 3 it gives us 13. Therefore, the number of students who chose mathematics were 13. When you come on to biology, you can see that we have a 1 bundle, and then also you have one student. So when you add them, 5 and 1 to give us 6. Chemistry, they are 4. Then in physics, they are 7. So with this, it gives us a total frequency as 13. Therefore, this teacher interviewed, or this teacher collected data or collected information from how many students? 30 students. So when we define data collection, we are saying that data collection involves gathering information, organizing information, and interpreting information. So when we gather this information, okay, you're going to ask a student that is gathering, okay, the student will say, you ask him or her, what is your favorite subject of these of science, among the science subject, which is your favorite subject? Then the student tells you, I like biology. Biology is my favorite science subject. Okay, that is you're gathering information. Then how are you going to organize this information? That's when you come up with the subject here. Then you may have come up with the tallies, and then you come with the frequency. So we are organizing this one, this information that we've gathered from what, from the students. Then we interpret after we have analyzed this information, that here we have the number of the subjects are here. Then here we have the number of what, of tallies. Then you have the frequencies, the number of students are liking a certain subject. So here we can interpret that so and so is the most liked, or it is the subject which has most what, which is liked by most students. That is interpretation. So correct data collection involves gathering, organizing, and then interpreting information. So common tools that we use include common tools that you can use in the process of gathering, organizing, and then interpreting. You're saying that you can use what called the tally charts, whereby you can see here also tallies were used. Tallies were used during that collection of that information. And then you can also use what called the pictograms, bar charts, line graphs, and then pie chart. We are going to look on how each of these will be used in details in some few minutes to come. So how do we illustrate this data? We can illustrate the data collected using what called pictograms. When we talk of pictograms, that's when we use we use what called pictures or images to represent certain information, and usually it could be something which is related. If you're talking about students, the pictures that we use on the pictogram, let them represent students. You don't be like talking about student and then you bring cows. Okay, so if you're talking about cows, the picture should depict a cow. If you're talking about cars, the picture should depict a car. If you're talking about balls, the picture should depict the ball. Okay, so for example, if this is my pictogram, if I'm representing balls, I will use balls to represent data. Okay, so if they are girls, if they are students, I need to represent them in terms of what, student. I can't represent students in terms of what, balls. So we use pictogram to represent when you use pictures or symbols that represent that certain variable, that type of data. Okay. Then you can also use what called the bar chart. You can use the line graph, or you can use pie chart. So let's look it in details here. For this case, if you talk about the pictogram, okay, we say that when we talk about the pictogram, that's when we use pictures of certain of that related data that we are talking about. So for this case, we want to we were talking about students, and then we were talking about the number of what, their favorite subjects, from biology, chemistry, math, and then physics. Which of these is your favorite subject? That was the question. Okay, that was the survey all about. So then the teacher analyzed or evidence that students liked the different number of students likes different what, subjects. Okay, so having got that information that was gathered, okay, so what could be next is, if you want to present this information that you've gathered on a pictogram, we use images which are related to students. For this case, we are talking about a student. So the images also that we are going to use, they should reflect what we call a student. Or we should not be talking about students and then for you, in your pictogram, you use cars. Okay? Use the car if you're talking about the data that you collected is about cars. Then use a house as a picture or a symbol if you were talking about houses. If you're talking about a person, use a picture which at least try to depict that this is right. This is really a person. So for this case, in our pictogram, we are using pictures or images which are related to what we call a student. So if you want to represent this information that was gathered, okay, depending on the on different numbers of students who prefer certain subject. For this case, we can see that how many students liked math? They were 13. So we represented the 13 using what we call these students here. So if you count also this, they will give you 13. So this is how we can represent. So this is math 13, biology, how many? There are 6. Chemistry, there are 4. And then physics, how many are they? They are 7. Okay. So you can see how we represented the information that we had. We had our math as 13, and then in biology it was as 6, and then chemistry is 4, and then this is 7. Okay. So you see how we have represented this information using what we call a pictogram. And indeed, there is this point that you should note that each picture represents a specific quantity, and a scale can be applied for larger values. Okay. If you look at this figure, the values that we have, these values are not large. These values are small. But if we come across that we have larger values, okay, let's assume if you have values like 130, 60, 40, 70, if these were the figures, it will be very hard for us to draw how many 130 students using these pictures. It will be very hectic. Okay. To draw 60, to draw 40, to draw 70 is a very hectic. Therefore, with that we can say, let this one boy or one girl represent 10 students. That is, if the values are large, okay, but since our values for this case, the number of students were few, that's why we just use them directly, because we can draw the 13, we can draw the 7, we can draw the 6, we can draw the 4 boys, okay, all students, we can just draw them on the pictogram. So if there are very many, it's better that you come up with a scale, and this scale should be indicated. So if I assume I had this number of what? This number, this data was to 130, the 60, 40, or 70. I was going to use a scale, and I was also going to indicate it here. Okay, I was going to indicate it here. So my scale would be, if it was that format, I would say one student represent 10 what? Or I would say one image, one picture of this represent 10 students. One picture of this representing students. So that is the scale I would use if the number of students were large. But since they are few, that's why I'm using this format. So from there we can again see how we can use this. That was all about what we call the pictogram, and then we can look at what we call the bar graph. Okay. We can also use bar graph to represent the data which can be given. So in this case, we saw that we had our biology, we had our math, we have biology, we have chemistry, and then we have physics. We saw that the math was 13, and then biology was having how many? Biology was having 6, and then chemistry was having 4, and then 7. Okay, so this information, the way it is, it can also be represented using what we call bar graph. So the heights and length of each bar corresponds to the frequency. So with this, if we wanted to draw come up with this graph, what you need to know, we're going to draw our, with any graph, we come up with our vertical axis, and then the y, and then the horizontal axis. Okay, so of this data that we have here we have the subject, and here we have the number of students. Which one would be on the vertical axis, and then which one would be on the horizontal axis? So those are some of the questions that you should ask yourself. Okay, if you're given this information, which data should be put on the vertical scale, or which data should be given on the horizontal scale? But usually, since these are the number of students, they will come in the number of subjects. These are subjects. Okay, subject will come on the horizontal scale, and then on the vertical scale we shall have what we call the number of what? number of students. Why? It's because uh, the number of students depend on the number of students depend on the subject. Okay, or the number of students varies with subjects. Okay, the number of students varies with subjects. That's why we're having number of students this side on the vertical axis and then subject on the horizontal axis. Therefore, we can say here we have from here. So let me come direct here. So this is my graph paper as you can see it here. Okay, so on this graph paper you can see that from here there is a space, then it starts from here 1 2 3 1 2. So also you can have another space 1 2 3 1 2 3. So you can create, you can come up with your appropriate scale, can come up with your appropriate scale. Okay, okay. Usually when you are talking about the bar graph or bar charts, usually they are not combined. They are not combined on each other. You can see that here there is a space, 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 and also at the end there is a space. Okay, so in this case, so if I draw my bar like this, and this represents, let's say, here on the vertical scale, on the vertical, we have what we call frequency, which is the same as the number of what? Number of students, okay? So remember down here we had the number of what? We had the subjects. So if you want to say biology, we have math here. So we come indicate depending on the low, on the biggest value is 13 and the lowest is 4. So you can also program your scale that you're going to use depending on the information you have. So here I can put my I can arrange my scale up to, since the maximum value here is 13, I can go up just 15 because 15 will be, the 13 will be under 15. So even if I stop at 15, there it will be okay. Okay. So then if I want to indicate where 13 is, let's assume this is my graph paper. So it can indicate from 1, 2, 3, 4, 5, 6, 7 upward 15. But remember our biggest value is the bigger value is 13 in this case. So if I want 13, I'll just come where 13 is. Let's assume 13 is here, and this is my biology, this is my math, so 13 will be there. So I can shade it like this. So if I want to count to see where biology is, and biology is 6, so I'll come on my scale of this scale. I see where 6 is, leave the space, see where 6 is, 6, let's assume 6 is here, and then also shade. So this is biology, this is math, and then come where there is chemistry. Chemistry there are 4 students. Come where there is 4, also draw. Come where there is physics, indication, check where physics is, also draw. So here you can start, you can come up with such a graph using representing the information that you've gathered on what called a bar graph, using what? Just using a graph paper, just what you need to choose the appropriate scale, choose put the right value, the right values where they should be, put the right values on the vertical axis, and also put the right values in the horizontal axis. For this case, for example, if you put wrong values on the vertical axis and then also put the wrong values on the y-axis, on the horizontal axis, then your data will be messed up with. So it is always better to choose the appropriate value to know where and where, like which data should go to the vertical axis and which data should go on the horizontal axis. So in this case, I would like to end it here. We still have more methods how we can represent data, whereby when we come back, we shall see on how we can represent data using a line graph, and then also shall see how we can represent data using what we call a pie chart. So